Thank you guys for attending today's talk. So, yeah, I'm a principal software engineer at Dremio. I basically lead the Reflections development. So today's talk is a pretty technical one. It's about partition and file pruning in the context of Dremio Reflections and Apache Iceberg. So let's get started. So in terms of the agenda, I just want to quickly talk to you what are exactly Dremio Reflections, right? Then we're going to talk about how partition pruning works during query execution, right? We'll look at some query plans, and then also talk a bit about how partitioning stats can help us with query planning in terms of like selecting the correct reflection to use, and also logical planning. And finally, we just open up to Q&A. Okay, so what are Dremio Reflections? Dremio Reflections is basically a technology that we have to accelerate user queries. But the way I like to think about it is that it's basically a relational cache that's basically backed by materialized views. Okay, and these views are transparently substituted into user query, which means that as a user writing a SQL statement, they don't actually have to directly reference the materialized views, right? You put them in. And so, to illustrate as an example, I mean, let's say you have this simple SQL statement, like select C1 sum C2 group by C1, right? And you're joining 3 different tables. So typically when you do query planning, you're going to convert this into a SQL node tree and then into a relational tree. And then at that point, this is when Dremio's planner will then figure out how to substitute reflections into this query plan. And one of the things that we do is we'll basically normalize queries into various alternatives that make substitution matching easier. So for example, in this example, you can see how this query gets turned into a relational tree that has an AG on top of a multi-join with these 3 tables. And the reason why we have a multi-join is because suppose these are inner joins, then you can swap the tables in any order and still get the same result, right? So so the query basically gets normalized into this form. And then we'll look for our reflections that can match into this query. And so suppose you got a reflection that has materialized an expensive join between table A and table B. And so then we will basically rewrite the query so it looks like this, right? And whether this plan actually gets used in the end, gets selected in, of course, it's still going to depend based on costs, right? And that's something we'll talk about a little bit later. Now, Dremio Reflections is basically married to Apache Iceberg because the reflection is physically stored in Apache Iceberg table format, right? And then we basically leverage the Iceberg metadata to do all the, partition and file pruning. So to give you an example, like, in the future slides, I'm going to be showing you a bunch of plans that are based on the San Francisco police incident data set. And oftentimes when customers use reflections, you're going to cache the same piece of data in different ways, right? Depending on the user query access pattern, right? So maybe you have a reflection that's partitioned by category, by day, and by day of week. And each reflection, as I said, is materialized in its own Iceberg table. And then the Iceberg table itself, underneath the covers, is going to, organize its underlying Parquet data files by, the Iceberg table's partitioning scheme. So that's what I've illustrated here. Now, in case, I think most people already know, like, what Apache Iceberg is, but underneath the covers, the way I think of it is basically it's a lot of metadata around your data files. And in our case, it's Parquet data files. So like at the bottom, you basically have lots of Parquet data files that represents the data inside your reflection, maybe partitioned by say, category, right? And then on top of that, then you've got manifest files that may be like, for each manifest file, you have a range of partition values, and they point to the data files, and then that's organized together into your manifest list, right? And then because you have different snapshots of your data, then you have these different snapshots, and then finally your catalog points to the most recent version, right? So, I mean, basically, the table format is a lot of metadata around these Parquet data files. All right. So the second agenda topic is basically exactly how does partition pruning work during query execution, right? Um, so in these examples, I want to illustrate using the San Francisco Police Incidents data set. And in this data set, I've got a pretty small data set. It's 2.2 million records based on the the year range that I pulled off the internet. And in order to show you the split and file pruning in action, I artificially set the max Parquet file size to 1 megabyte, right? But actually, in reality, you usually want to set your Parquet file sizes like the 256, 512 megabyte sizes, right? But just for the demo purposes, I set it really small so that we generate a lot of files, a lot of splits, right? In this data set, I just want to point out that the category field has 39 distinct values, and the day of week obviously has 7 distinct values. All right, so because we're going to be looking at query execution, we're already done with planning. So let's make an assumption that you've got a user query access pattern that can benefit from a reflection like this, right? So this reflection is basically partitioned by category and then sorted by day of week, okay? So once you build this reflection, then this reflection is stored as an Apache Iceberg table in your distributed storage. And so let's take a look at what that Iceberg metadata looks like, right? So the first thing that you have is your manifest list file, right? And so the manifest list file lists all the manifest files. And for each manifest file, you have your lower and upper bound partition value, right? And so what this means is that, like, if you've got a query that comes in that filters on, for example, category equals arson, right? Then you only need to open up this particular manifest file to find your Parquet files. You can prune out all these other files, right? So in this example, just keep in mind that I have 18 manifest files in this reflection. All right. Now to drill down this hierarchy of metadata, let's look at the manifest file associated to the larceny theft partition value. So what you notice here is that this partition value contains 21 Parquet files, right? And because I did a local sort on day of week, right, then these Parquet files are basically sorted by day of week. And so what that means is that, like, if I filter on this partition value and a particular day of week, I'm likely not going to need to open up every single Parquet file because for example, Friday is going to be localized to a much smaller number of Parquet files. It's not going to be scattered across all Parquet files. So basically, that's going to be a second level of pruning that you can do, right? In addition to any other additional columns, that you filter on, because this manifest file also has the lower and upper bound values for every column that's in the Parquet file. And then finally, I want to point out that, like, if you were to just run like a simple Unix command like find all the Parquet files and count the lines, you'll come up with 115 splits or files, right? So in this particular reflection that's stored in Iceberg, I have 115 physical Parquet files, right? Okay. So let's take a look at the query execution and see the partition pruning in action, right? So suppose you have this query, right? So you're basically you're gonna group by PD district, right? And then count one, and then filter on category is equal to larceny theft, and day of week is equal to these two values, right? And because we know category is a partition, is one of the partition fields, we're going to see, like, we would expect to see partition pruning on this category column. Now, if we look at the physical plan for this query, this is just a snippet, right? But the way that you read these query plans is you read them bottom up, right? So 0203 is the first operator, which corresponds to the manifest list file scan, right? And here we can see that it has pushed down that partition filter where category is equal to larceny and theft, right? So this will do the first level of the manifest file pruning. And then the next operator on top, 0202, is now scanning the manifest files, which are looking for which Parquet files do I then need to go and scan, right? So here we've also pushed down both the category and day of week filters. And remember, because we did a local sort by day of week, we're going to expect to prune out many Parquet files, right? And then finally, 0104 is the operator associated to the Parquet file scan, right? And here we're going to do additional pruning because now the row groups, we're going to do row group header pruning. And here, because the Parquet files don't scatter the days of week values, we're going to also be, the rows that we read from each Parquet file are likely to be from Saturday and Sunday. There may be other ones, but most of them will be Saturday and Sunday. So let's take a look at how this looks inside the actual execution plan. So this is a screenshot from Dremio's query profile analyzer, right? And these are the actual number of records coming out of each operator, right? And so for the Iceberg manifest list file scan, you can see that 7 records come out for this query, right? So we basically pruned from 7, basically pruned out, what is that, six files, right? So we're left with 7. So it's only 7 manifest files came out of the Iceberg list file scan, right? And this is the first level of pruning where we filtered on category is equal to larceny theft. And then if you look at the second, if you look at the operator above, 0202, this table function is associated to the manifest file scan, right? And here you can see we pruned a lot of Parquet files, right? We went from 115 down to 7, right? So this is the 7 Parquet files that we have to open up, you know, to satisfy that user query. And then 0104 corresponds to the Parquet data file scan, right? And then you can see that we open up the 7 Parquet files, and we basically scan about 150K records, right? And then on top of that, we have to go and apply the Saturday and Sunday filter, and that results in 140K. But you can see that this number and this number is pretty close together, right? Because most of the data, as I said before, that comes out of these Parquet files are associated to Saturday and Sunday because we sorted the data by day of week. Another thing interesting to point out is you can see that there's like this lightning bolt icon. So that tells us that our data was scanned from the materialized view or the reflection. All right. All right, so just to give you, you know, to look at what happens if you didn't have a partition, right? If you didn't have partitioning of sorts, this is how the query plan would have looked like, right? So in this case, 0202 corresponds to the manifest file scan, which produces the Parquet files that you have to, you know, each that you have to go and open up and look. And so here we have 89 files, right? 89 splits. So this is significantly a lot more than 7, right? And then the other thing to note is that when you actually go ahead and scan the Parquet files, you know, now we're coming out with 480,000 records as opposed to 150,000 before, and that's because each Parquet file now contains a lot, you know, other days of week, right? And now we have to do additional filtering on top to get that down to 140K. So, I mean, it's pretty clear. Like, if you want performance, you need to do, you know, one way to do it is to design your partitions and your sorts correctly so that you maximize, you know, your pruning, you know, at all the different levels, at the Iceberg manifest list file, the manifest file level, and also the Parquet row group level. Okay, so let's take a look at our third agenda item, which is how partition stats can help with query planning. So, you know, when it comes to query planning, you know, you have to figure out like what plan will have you know, the lowest cost, and there's going to be lots of different alternative plans, right? And so, you know, in this example, right, I have 3 reflections, A, B, and C, right? So which one should I use, right? And also maybe I have a combination like A and B or A and C. And finally, once I figure out which combination of reflections should I use in my query, I also need to do join ordering, right? So for example, if I'm doing a hash join, I want to have the bigger table on my probe side and smaller table on my build side, right? So in order to make these type of decisions, right, you need a cost-based optimizer that has good estimates, right, of the row counts coming out of the different scans. And so partition stats can help with this because it can help you get more accurate row count estimates. All right, so let's take a look at an example. So, suppose you have a query that looks like this, right? You're just projecting 3 columns, and then you're filtering on category equals burglary. In this case, dir0 is an implicit partition column in the underlying data set, meaning that the underlying data set is already partitioned by category here. And then also filtering on day of week equals Sunday, right? So when planning this query, this is one option, right? Which is to go directly just scan the base table, okay, with no reflection, because the base table is partitioned by category. Now let's imagine for this example that I also create 2 additional reflections. So here, I'm going to partition by day of week, and you can see it's checked here, right? And now I'm also going to create a second reflection that doesn't partition by any columns. And oftentimes customers may do this because they maybe they want to accelerate like slow physical storage, like maybe the data is stored in JSON or CSV, but they want to have the data physically stored in Parquet file COM store format, right, which is much more optimized for querying. So anyway, these are 3 different alternative plans that could be considered for answering this user query. Okay. So now let's take a look at the logical plan in terms of how we determine which one should we use, or which one should a planner use. So this is the first plan, logical plan, right? And it, this plan turns out to be the best plan to use. And this is the one that doesn't use a reflection and scans a base table, right? And if you look at the logical plan, it's pretty simple, right? It was just a project on top of a scan, right? And here the scan, if you look at the table involved, this is the actual underlying base table, right? Incidence. And we can see that, first of all, that a partition filter was pushed down, right? And here it was on category equals burglary, right? And then besides that, there was also the other filters, like the day of week, this non-partition range filter here on Sunday, right? Now, the estimated row count for this scan was 13,000. And where did this number come from? So because this there was this partition filter was pushed down, we were able to access partition stats on this Iceberg table to get a very exact row count for how many rows are in burglary, right? And based on this number, then we further reduced this using heuristics based on the filter on day of week equals Sunday, right? So that number is further reduced, by some heuristic factor, right? And that results in 13,000 estimated row count, right? And so so the planner, right, from when it's doing its the cost-based planner is trying to figure out which plan to use. This 13,000 is very key in terms of trying to cost which plan to use. So let's look at what happens with the second plan. So in the second plan, you can see here, this is the one that is scanning the materialized view that's partitioned by day of week. And in this case here, you see that the table here that's used is the actual reflection. So this is the reflection ID and this is the materialization ID, right? And in this case, the partition filter that we pushed down was the one that's on day of week equals Sunday. And so, for this particular partition value, we were able to get a very accurate row count. And then from there, we further reduced it based on that category filter. And this resulted in 17,000 rows. And so, because 17,000 is greater than 13,000, then this plan was not selected, right? And then finally, if you look at the third plan, the one that had no partition, right? The reflection that had no partition, you can see here, again, we're still scanning a different reflection table, right? Reflection is different reflection ID, but we come up with a much higher row count estimate. And so where did this row count estimate come from, right? This row count estimate comes from knowing that the total number of rows in the table, which we have, and then we further reduce it, using rules in terms of like, okay, I've got a category filter equals burglary, and another one for day of week equals Sunday. So we further reduce the count, but it's not going to be, as accurate as like the first two plans where we actually had the partition stats, right? So, but I just also want to point out though that like, we do support like analyze table command on Iceberg tables, and so that can help you generate more accurate stats that we can use during planning. Okay. So in summary, your reflection partition design is going to be based on your user query access patterns. And so what that means is that like, if you're trying to accelerate some dashboard, right, and your dashboard always filters on some column or always prompts on some column, right? And that column is like, say, low to medium cardinality. That would be a good column to consider like partitioning on your reflection. And this piece of advice is especially true when your reflection is placed on the top of your semantic layer in Dremio, right? Right when it's right underneath, like your dashboards or reports. And I mean, and for the second bullet, fundamentally, the reason why you're partitioning and sorting your reflections is to really fundamentally minimize, the expensive data access, right? I mean, like if your reflection has, 100,000 splits, right? 100,000 files, right? You want to minimize how many Parquet files you actually go and have to open up and scan, right, to satisfy the user query. And then as I showed you, is that basically the reflection design, the partition design is important across all phases of planning, right? So in planning, you can see how it helps the cost base optimizer pick which reflections to use to help with join ordering, right? And then also like during execution, you'll see the actual splits like being pruned, right? And it was pruning at different levels. It was pruning at the manifest file level, manifest list file level, manifest file, and in the Parquet files, Parquet row groups. And then everything I've showed you here is that pruning logic, even though I showed you in the context of reflections, it's true for any Iceberg table that the Dremio Sonar query engine queries, right? Like if you look at the plans, it's the same logic, right? So you can observe like the pruning happening and the partition filter push downs, right? And then finally, I just want to point out there's two more resources you can go to learn more about this or get help. First of all, today's presentation is based on like a blog that was published maybe two weeks ago on the Dremio website. It's called this, right? So you can just go directly to Dremio's website and read more about everything I talked about today. The blog contains the full query profiles, so you can see the full plans, both logical and physical planning. And then finally, we've got a Dremio community, a forum online that you can just also ask questions and get help. I'm pretty active in there, so if you like at me, I'll be able to respond pretty quickly. Okay, so yeah, thank you for attending my talks.